Hello students, I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our series on triangles for class 10 student. Note that this complete series is as per the latest updated syllabus, and in this complete series we will cover all these chapters using the power of animation and the visual tool to make the tough concept easier for you. In this lecture we will cover the exercise 6.3 question number 1 to question number 5, and the link to all the lectures is given in the description. Check it out. And students, one important thing, do not forget to download the PDF of the concept and formula list. The link is given in the description. That will be really helpful to solve the question and also brush up the concept whenever you are having the exam or whenever you need so. So without taking any further time, let's start with this lecture. Best of luck. Question number 1. State which pair of triangles in figure 6.3 are similar. Write the similarity criteria used by you for answering the question and also write the pairs of similar triangle in the symbolic form. So various figures are given. We have to check whether the two figures in each part are similar or not. Before taking down the question, let's have a glimpse of the three criteria for the similarities of the triangle. The first criteria is AAA criteria, that is angle criteria, in which if the two triangles are having the corresponding angles as equal to each other, then we can say the two triangles are similar to each other. The criteria is AAA criteria, that is angle criteria. This criteria we can also write as AA criteria, that is if only two angles are matching, then also we can say the two triangles are similar to each other. Why? Because if the two angles are matching, the third angles will automatically be equal to each other because of the property of the triangle. That is, the sum of the three angles of a triangle is 180 degree. If two angles are matching, the third angle will automatically match. So we can write AAA or AA. Both are basically same. The second criteria is SSS criteria, that is side criteria, in which if the ratio of all the three corresponding sides are equal, then we can say that two triangles are similar to each other. Note that here we are talking about the ratio of the corresponding side, not the corresponding side. The ratio of the corresponding side must be equal. Got it? The third is SAS criteria, that is side angle side. If ratio of two set of corresponding sides are equal and the angle in between the two corresponding sides are also equal, then we can say that two triangles are similar to each other. So these are the three criteria based on which we will solve the question. One more important thing, the sequence of the vertex of the triangle also matter. If we are writing ABC is similar to the triangle DEF, here A and D are matching with each other, B and E are matching, and C and F are matching. Means these are the corresponding angle. We cannot write ABC as BCA. It will be wrong. The set of the corresponding angles should match with each other. We can rotate the triangle, we can flip the triangle, but this sequence should match with each other. Okay, the sequence really matter in the similarities of the triangle. In the questions, we will see many times the triangle is not straight. Basically, the triangle is flipped or rotated. That is, the vertex are not given in the sequence. In that type of question, we have to rotate and rearrange the vertices to match the sequence. The exact thing we will see while taking down the question. Okay. Let's take the first part, in which we are given the triangle ABC and triangle PQR. Here on observing, the three angles of both the triangles are given. Angle A and angle B are given as 60 degree, that is both are equal to each other. Angle B and angle Q are given as 80 degree, both are matching. Similarly, angle C and angle R are both given as 40 degree. The three corresponding angles are exactly matching with each other. So we can say both the triangles are similar to each other based on angle criteria, that is AAA criteria. So we can write the triangle ABC is similar to triangle PQR. Here angle A and angle P are matching, angle B and angle Q are matching, and angle C and angle R are matching. So that is for the part 1. Let's move to part 2. Here we are again given the triangle ABC and PQR. This time we are given the three sides of the triangle. Here AB is 2, AC is 3 and 2.5 is the BC. Similarly 6, 5 and 4. If you directly observe the two triangles, here the concept of the ratio of the corresponding sides will be applicable. Why? Because angles are not given. If we have to check the two triangles are similar or not, we will check the ratio of the corresponding sides are equal or not. Here if we take AB and PQ, that will be 2 by 6, that is 1 by 3. If we take AC by PR, it will be 3 by 5. And if we take BC by QR, it will be 2.5 upon 4. So basically by looking, we can say both the triangles are not similar to each other. But this question is having a trick. The trick is that the right hand side triangle, that is the triangle PQR, is shown in the rotated form. If we rotate this triangle, now the side 2 is matching with side 4, side 3 is matching with side 6 and side 2.5 is matching with side 5. Basically 2 by 4 is 1 by 2, 3 by 6 is 1 by 2 and 2.5 upon 5 is 1 by 2. Now we can say the corresponding sides are matching. Basically in the first time we have not taken the right corresponding sides. We have taken the wrong one. Here AB will correspond to QR and AC will correspond to QP and BC will correspond to PR. And these are the corresponding side and the ratio of these corresponding sides are equal to 1 by 2, basically equal to each other. So we can say here both the triangles are similar to each other by SSS criteria, that is side 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 criteria. But the trick is how we will write this triangle as similar. We will write triangle ABC is similar to triangle QRP. Here A should match with Q, B should match with R and C should match with P. So the sequence of the vertex of the triangle matters in similarity. So this is a perfect example of that. Okay. We cannot write triangle ABC is similar to triangle PQR. Here we have to write ABC is similar to QRP. The sequence matters. Let's move to part 3. Here again we are given two triangles and the sides of the triangles are given. Let's see whether the ratio of the corresponding sides are equal or not. If we observe 2.7 upon 4, if we take these two corresponding sides, it is 2.7 upon 4. If we take these two corresponding sides, it will be 3 by 6, which is basically 1 by 2. And if we take these two corresponding sides, it will be 2 by 5. So we can say the corresponding ratios are not matching in this triangle. You can rotate the triangle, you can flip the triangle, you can do anything. Still, the ratio of the corresponding sides will not match with each other. So these two triangles are not similar to each other. Got it? These two triangles are not similar to each other because by rotating, by flipping, by doing anything, the ratios of the corresponding sides are not matching with each other. Got it? Let's move to the fourth part. Here triangle NML and QPR are given. Let's check whether they are similar. One angle is given and two sides are given. Okay. Here angle M and angle Q are matching, that is 70 degree. Let's rotate the right hand side triangle to match this 70 degree with 70 degree. Here M and Q are matching. So the corresponding angles are matching. So we can rotate this triangle for better clarity and better visualization. In the exam also you can draw a small triangle on the right side of the figure, the rotated one. It became easy to exactly match both the figures. So we have rotated the triangle, 70 is matching with 70. Here MN will correspond to QR and ML will correspond to QS. By doing so, let's check the ratio of the corresponding side. It will be 2.5 upon 10. That will be 1 by 4. And Mn upon QP will be 5 upon 5. That is 1. So here both the triangles are not similar to each other as their ratio of the corresponding side are not matching. But wait, hold, one more trick is here. Here the ratio of the corresponding sides are not matching. But if we just flip the triangle with the axis around the angle Q, here we got the corresponding side to Mn as QP. Got it? Now if we take the ratio of Mn upon QP, it will be 2.5 upon 5, that is 1 by 2. And if we take the ratio of ml upon qr, it will be 5 upon 10. That is 1 by 2. Now the ratio of the corresponding sides are matching. Are you able to analyze this figure? Here we have rotated the triangle and also flipped the triangle around the q axis, that is axis around the q angle. So you have to rotate the triangle, also flip the triangle to match the corresponding sides. Then only you can be sure that the ratio of the corresponding sides are matching or not. Now if you observe two set of corresponding sides ratio are matching, and angle in between the two corresponding sides are also matching. So by SAS criteria, side angle side criteria, both the triangles are similar to each other. Got it? So how we will write both the triangles are similar? We will use the corresponding angles. So triangle NML will be similar to triangle PQR. So a tricky question but very important question. So every time you have to rotate and flip the triangle. Or you can apply the small trick. You can just observe the sides of both the triangle and you can check whether any ratio is coming. Like here 5 is basically double of 2.5. And on observing 5 and 10, you can observe that 10 is double of 5. So 2.5 and 5 ratio is 1:2, and 5 and 10 the ratio is again 1:2. So in this way you can observe whether the two sides are in the same ratio or not. And by doing so you can rotate or flip the triangle accordingly to match the corresponding sides. Okay. Let's move to part number 5. Here triangle ABC and triangle DEF are given. One angle is given 80 degree, angle A, and angle F has also 80 degree. Two sides are given, and in the second figure also two sides are given. Here 2.5 and 5 are basically 1:2, and 3 and 6 are again 1:2. So something it is matching. Let's flip the triangle to match the ratio of the corresponding side as equal. That is AB should match with DF because the ratio is 2.5 upon 5, that is 1:2 or 1 by 2, and BC with EF 3 by 6, it is 1 by 2. On flipping the triangle we got one set of corresponding side as equal, but we are not able to get the angle between the two corresponding side. Here these angles are missing. Some additional angle are given which are given as equal. In that case one of the side is missing. Basically we are not having the complete data to check whether the two triangles are similar or not. So we can say these two triangles are not similar to each other because none of the criteria AAA, SSS or SAS are matching. Got it? So let's move to the last part, part 6. Here we are given the triangle DEF and the triangle PQR. Here two angles of the triangle are given. One angle is missing in both the triangle. In the triangle DEF 70 and 80 degree are given, and in the triangle PQR 30 degree and 80 degree are given. Angle E and angle Q are matching equal to 80 degree, but angle D and angle R are not matching. Let's find the third missing angle using the sum property of the triangle. That is, the sum of three sides of a triangle is 180 degree. So in the triangle DEF, angle F will comes out to be 180 degree minus 80 minus 70. So angle F is 30 degree. Similarly, let's find the angle P, that will be 180 minus 80 minus 30. That will comes out to be 70 degree. So we got all the three angles in both the triangle. Now on observing, we can see the set of the three corresponding angles are matching. Here 70 degree are matching, 80 degree are matching, and 30 degree are matching. So we got both the triangles are similar using the AAA criteria, that is angle criteria. So let's write it down. Triangle DEF is similar to triangle PQR. Got it? D is matching with P, E is matching with Q, and F is matching with R. So we got this triangle as similar to each other. So we have done with the question number 1. Long question. It is having 6 parts. Let's move to question number 2. In figure 6.35, triangle ODC is similar to triangle OBA. Angle BOC is 125 degree and angle CDO is equal to 70 degree. Find angle DOC, angle DCO and angle OAB. So let's observe the figure. Here we are having two triangles. Triangle ODC and triangle OBA, these are the two triangles which are given as similar to each other. Further, angle BOC is given as 125 degree and angle CDO is given as 70 degree. And we have to find these three angles. Okay, so let's proceed with this question. Here these two triangles are given as similar to each other, and we know in the similar triangle the corresponding angles are equal. And by looking at the sequence of the vertices of the triangle, we can check which angles are equal. Here angle O is matching with angle O, so these angles are equal. And angle D is matching with angle B, so these angles are equal. And angle C is matching with angle A, so these angles are equal. One important thing to be noted here is that by just looking at two triangles as similar to each other, do not blindly match the sequence. Like D is matching with A, C is matching with B. Just do not blindly match the angles. Just check what the nomenclature or what the sequence of the vertices are given. Based on the sequence only, match the angle. Here angle D is matching with angle B and angle A is matching with angle C. That is in the crisscross, okay, not in the straight format. So this point you should keep in mind. The question framer may give the tricky sequence so to confuse you. So do not be confused in the exam and follow the proper order. Let's proceed. Here angle BOC is given as 125 degree. Can we find this angle using the concept of linear pair? That is, sum of both of these angles on a straight line is equal to 180 degree. It means angle BOC plus angle COD will be equal to 180 degree. One angle is given. We can find angle COD as 180 minus 125, which is 55 degree. So we got angle O or angle COD as 55 degree. If you observe the triangle ODC, this triangle, here we are having two angles. We can find the third missing angle using the sum property of the triangle. That is, the sum of three angles of a triangle is 180 degree. So let's find the third angle. That will be equal to 180 degree minus 55 minus 70 degree, which is 55 degree. So we got two angles of this triangle as 55 degree and one angle as 70 degree. And in the starting we have seen that both of these triangles are similar to each other, and angle D and angle B are equal and angle A and angle C are equal. And in the question we have to find the angle A, that is angle OAB. So angle A and angle C are equal, so angle OAB is also equal to 55 degree. So all the three missing angles in the question are 55 degree. That is the answer of this question. So we got the answer of question number 2. One important thing to be noted from this question is that do not blindly match the angle. Match the angles only as per the sequence of the vertex of the triangle given in the similarity equation. That is, triangle ODC is similar to triangle OBA. So match O with O, D with B and C with A. This is the understanding that we got from this question. Let's move to question number 3. Diagonal AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at the point O. Using the similarity criteria for the two triangles, show that OA upon OC is equal to OB upon OD. Let's observe the question. In this question, a trapezium ABCD is given. Let's draw the trapezium ABCD. Trapezium has a property that is one set of opposite sides are parallel to each other, which are given as AB and DC. So AB and DC are parallel to each other. We are also given the diagonals of this trapezium as AC and BD. Both of these diagonals are intersecting at the point O. And we have to show or prove that OA upon OC is equal to OB upon OD. For simplicity, let's give the name to the angle as angle 1, angle 2, angle 3 and angle 4. Okay. Here AB and CD, the sides of the trapezium, are given as parallel to each other. Two lines are parallel, so we can apply the concept of the transversal. That is, the parallel line AB and CD are cut by the transversal AC and BD. Let's take the transversal as AC. In the transversal, we know the alternate angles are equal. These are the alternate angle, means angle 3 and angle 4 will be equal to each other. If we take the diagonal BD as the transversal, which is cutting the two parallel line AB and CD, here these two angles are the alternate angle which will be equal. So we got angle 1 is equal to angle 2 and also angle 3 is equal to angle 4. these angles are equal to each other. Further, let's observe the triangle OAB and OCD. Here, if you observe these two triangles, all the three angles will be equal to each other. Angle 1 and angle 2 are equal to each other, and angle 3 and angle 4 are also equal to each other. The same we have just proved as equal as an alternate angles. And angle O, that is these two angles are vertically opposite angle, so that will be equal to each other. So by angle criteria, that is AAA criteria, we can say both the triangles are similar to each other. In the mathematical form, we will write the triangle AOB is similar to triangle COD. A correspond to angle C and B correspond to angle D. Once we got the two triangles as similar to each other, we can apply the concept of similarity, that is the ratio of the corresponding sides will be equal to each other. Here OA and OC are the corresponding sides and OB and OD are the corresponding side. So we can say OA upon OC will be equal to OB upon OD. That is the answer of our question. Got it? Before moving to the next question, firstly let's understand how to approach such type of questions in the examination. The question will not be straight, the question may be slightly twisted. So understanding of the concept is very important. How to approach such type of question in the exam? Let's see. Here in the question, we have to prove OA upon OC is equal to OB upon OD. You can segregate what is OA, what is OB, OC and OD. Here OA and OB are forming the triangle OAB and OC and OD are forming the triangle OCD. So these two triangles, if we prove as similar to each other, then by the ratio of the corresponding sides as equal, we can easily prove our final answer. So this is the approach. Identify the line segment that is given in the end result that we have to prove as equal and try to form the triangle out of that line segment. Here we are able to find the two triangles and just we have to prove the two triangles as similar to each other. Just the understanding on how to approach the question, because in the exam the question will not be same. It will be slightly tricky. Further, let's move to question number 4. In the figure 6.36, QR upon QS is equal to QT upon PR and angle 1 is equal to angle 2. Show that triangle PQS is similar to triangle TQR. So let's observe the question. Here in this question, one big triangle is given QTR and which is having several triangles inside this big triangle. Here it is given QR upon QS is equal to QT upon PR. Further, it is given angle 1 is equal to angle 2. And we have to prove or show that triangle PQS is similar to triangle TQR. So let's see how we can approach this question. Firstly, let's identify the triangle which we have to prove as similar to each other. This is a triangle PQS and this is a triangle TQR. So how we can prove the two triangles as similar to each other? Either we can prove the angles, the three angles are equal, or we can prove the ratio of the corresponding sides are equal. Or we can use the SAS similarity rule, that is the set of two corresponding sides, the ratio is equal and the angle in between them is equal. Let's see what we can use here. Here in both of this triangle, angle 1 is common. If we somehow able to prove the ratio of these corresponding sides as equal, then we can say both the triangles are similar as per SAS criteria. These two corresponding sides and the angle in between them, SAS criteria. Note that we are just discussing the strategy. If we are able to prove the ratio of the corresponding side of both of this triangle as equal to each other, then we can say by SAS criteria both the triangles are similar to each other. So let's take the corresponding side. Here QR is corresponding to QS and QT will correspond to QP. So the corresponding ratio that will form is QR upon QS is equal to QT upon QP. Somehow we have to get this equation. Let's see how we can get this equation. Once we get this equation, by SAS rule we can simply say both the triangles are similar to each other. Let's see. Here in the question it is given QR upon QS is equal to QT upon PR. If we compare both of this, here the three terms are matching. Here only the term PR and QP are not matching with each other. If somehow we are able to show or prove PR and QP are equal to each other, then we can easily solve this question. Firstly, let's identify what is PR and what is QP. This is PR and this is QP. Here, if you observe the figure, these two are the sides of the triangle PQR. So this is a triangle PQR in which angle 1 and angle 2 are given as equal to each other. We know the property of the triangle. The side opposite to equal angles are equal to each other. So angle 1 and angle 2 are equal. The side opposite to these two angles will be equal to each other. So we can say QP and PR will be equal to each other. So we got QP and PR, both of these terms as equal to each other. Let's replace PR with QP. So we got QR upon QS is equal to QT upon QP. These are the ratio of the two corresponding sides of these two triangles. So the ratio of the two corresponding sides are equal and the angle between the two corresponding sides are equal. So we can say the triangle PQS is similar to triangle TQR using the SAS similarity rule. Side, angle, side. These are the two corresponding sides and this is the angle in between the two corresponding sides. Got it? We have applied the SAS similarity rule and we have proved the triangle PQR is similar to triangle TQR. I could have easily started with the solution, but I have used slightly the long approach to tell you how to approach the question. What you should think in the exam to solve the question. I could have started by taking angle 1 is equal to angle 2, so the opposite side will be equal. But I have not gone directly to the formulas. I have used the approach how to solve the question. So we have done with the question number 4. Let's move to question number 5. S and T are points on the side PR and QR of the triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. So this is the question. Let's approach the question. Here let's take the triangle PQR. We are having the point S on the side PR and having the point T on QR. Further, it is also given angle P is equal to angle RTS. These two angles are given as equal to each other and we have to show the triangle RPQ is similar to triangle RTS. Let's take out the triangle RTS from the given figure for easy clarity and for easy visualization. Here we have to prove triangle RPQ as similar to triangle RTS. Let's match the sequence of the corresponding angles. R should match with R, P should match with T and Q should match with S. So we have flipped the triangle to match the vertices. Here angle P and angle T are given as equal to each other and also angle R is common. So the two corresponding angles of both the triangles are equal to each other. It means both the triangles are similar as per angle-angle criteria. Two angles are equal. It means both the triangles are similar to each other. That is the answer of the question. So are you able to imagine what is the role of visualization in solving this question? You have to identify the triangle and match the triangle with the given items in the question. Here we have taken the triangle out of the figure, we have flipped the triangle and we have matched with the given items. So don't underestimate the role of the visualization. It is very, very important. Use your creativity in solving the question. So students, we have done with this lecture. Hope you have enjoyed the lecture created using the power of visualization, our unique way of teaching. And do not forget to download the formula and the concept list. The link is given in the description. And also this series or this lecture is part of the complete series on the triangle. The link to all other videos are given in the description. Also check it out. So thank you very much for being with CREATA Classes. Have a great day and meet you in the next lecture. Bye for now.